Hello, our viewers. Welcome to the Zambezi River Authority Environmental Lab. You remember last time when we were on the lake, we collected samples from selected stations, and I mentioned during that time that we do on-site measurements of some parameters, and we also do some parameters in the lab, and this is the environmental lab. I'm going to hand you over to Mr. Kashole so that it gives you the details of exactly what goes on within this lab.
Welcome viewers, welcome to the environmental lab. I'll just take you through what we do here. Normally samples come from the Zambezi River, Lake Kariba, some portions of the Lake Kariba. Once the samples are collected, they are brought into the lab, into this laboratory, and this is where we do the further processing of the samples. So we do parameters that we're not able to do in the field. Parameters like ammonia, nitrates, nitrites, phosphorus. These are done in the lab. So currently, this piece of equipment, what it's doing is it's analyzing for ammonia and nitrite in the samples. So we've got about 30 samples. As you can see, the piece of equipment there's an auto sampler here connected to a computer, as well as this unit, which is basically the main unit. So what it does is you put your samples in the auto sampler. Of course, you ID them using the program on the computer. Then we've got a pump here and the reagents. So the pump pumps the reagents, mixing them with the sample, and then the reaction takes place. So what you see here on the screen, this is the results that we are getting from the samples that are undergoing processing. So this unit is called the Sterilization, and it's able to do about 100 samples in an hour. And it's a dual channel, so meaning it can do two parameters simultaneously. So currently we are analyzing ammonia and nitrite. So we've got about 30 samples, and of course 6 calibration standards. So after about an hour or so, but since some samples are less, so it will take maybe less than 30 minutes, the whole process will be done. And the system is designed in such a way that you're able to generate your calibration curve, your reports from here. So what we have here is this is a visible spectrophotometer. It's also used for analysis of water samples. So this one we can also do nutrients, and other parameters, iron, name them, depending on if you have the right reagents. What we have here again, this is a centrifuge. This one, basically we use it for removing or separating, clarifying our water samples. In case the water sample has got a lot of suspended solids. So what you want is a clearer sample. So all you do is you put it in a centrifuge. The centrifuge will be able to separate the liquid part from the solid part. Then here, these are pipetters. This is our main bacteriological lab. This is where we process samples for coliform bacteria. So basically, with the equipment here, we are able to do total coliform, and also able to do fecal coliform. So we've got an incubator here. We've got a sealer and the chemical. So this system is called the colilate system. So you get your sample, put your colilate 18, and then incubate at 44.5 degrees Celsius for 18 hours. And after that, you get your results. So an example of the results that we got, this is for dam wall downstream. As you can see, There are these wells that some are clearer than others. In short, there are positive ones and negative ones. So this method is just basically a statistical method. Which is, from these results, you refer to your table, which is a statistical table, and you're able to so from this table, you're able to quantify the coliform bacteria that was in the sample. So what you have here is a block digester. So this one, we use it for things like total phosphorus, total nitrogen. It's able to digest. Of course, you mix your sample with the digestion solution, and then you heat it up. So the complex phosphorus will be broken down to simpler phosphorus, which you can later determine using the available methods. Next to it is a paramixer. This is basically a vortex mixer. It is used for thorough mixing of a sample. Then what we have here, this is a titrator. It's a manual titrator. This as well is also this is also a titrator, but this one is an auto titrator. The manual titrator, of course, the endpoint is determined by visual, where you change your indicator changes color, and then you. But for this one, you program it in such a way that the endpoint will be determined by the probes that you put there. For instance, if you are doing things like total salinity, you can define your endpoint, say pH 4.5. So all you do is you put your sample there, your titrant, and then when it reaches 4.5, automatically it will stop, and it will give you the amount of titrant that has been used in that sample. These are dispensers, these two. These are basically, they're used for dispensing whatever reagent you want. You say you want to dispense 1 ml or 2 ml. They are basically repetitive dispensers. Then these ones are pipetters. These are pipetters. They're also used for dispensing small quantities of the reagents or the sample. What we have here is a distiller. So this is a piece of equipment that is used for the production of distilled water. Now in the lab, we don't use ordinary water for making reagents, so we use distilled water. But other than that, we also have a water deionizers. So this one is used for production of ultra pure water. So the water from here is what we use for making our reagents. Dilutions, all that stuff, we use ultra pure water.
Can we also drink that water?
No, because most of the ions have been taken out, so it's not healthy. Then what you have here is a fume hood. Then under it is a block digester, similar to the salt digester we saw there, but this one is a bigger capacity digester. So this one is also used for digesting samples. If you are doing things like total phosphorus, total nitrogen, total metals, you can use this piece of equipment. Then the fume hood, of course, its job is to make sure that the person operating is not affected by the fumes that are produced by the samples that are undergoing digestion. Because in digestion process, we basically use things like acids, those chemicals that actually can affect your health. So this one is there to protect the operator and also the environment. We've got an autoclave. So this is, we use it for sterilizing samples meant for bacteriological sampling. So as you might be aware, bacteria is found everywhere. So we want to make sure that the sampling bottle you are using for sampling, let's say fecal coliform, has to be free of the viable organisms. Yes. So it runs, it's similar to a pressure cooker, though it runs at high temperature. At high pressure and high temperature. Yes. So other than sterilizing our sampling bottles, we also use it for digestion of samples, such as if we are doing total phosphorus, total nitrogen. So you can also use, apart from using the block digesters, you can also use the autoclave. Okay. So what we have here is a glassware washer. So instead of doing manual washing of our glassware, we actually acquired this equipment. It's basically similar to a washing machine, but it's meant for washing labware. So all the dirty bottles, sampling bottles are washed in this glassware washer. Then what we have here is an oven. So this oven, we use it for drying our glassware, as well as if you want to do dry sterilization, say for bacteriological sampling bottles. So you can do dry sterilization. It's usually done at about 160 degrees Celsius for at least 30 minutes.
Zambezi River Authority. Water today, tomorrow.